My name is Joe DiTore, and we would like to go ahead and start this presentation right away. What I want to do is just make sure that you guys knew that I don't have an ability to answer questions while I'm doing this. So if you could do me a favor, write down on a sheet of paper some notes or whatever that you could go back to and ask questions at the very end, because hopefully this is provocative enough to have you answer questions or ask questions, but I will take all those questions at the end. What I'd like to do is a couple of things through this presentation. Mostly, it's putting the person back in the sea, putting the human back in the sea for exploration. We did this a lot in the 1960s and the early 70s, and then we had some catastrophes happen in the U.S. Navy. And from that point forward, almost all research that was in the sea actually stopped. So a group of us got together, MDs, PhDs, and we decided to try and make this project go forward. And this is part of the IANTD Aquanaut certification. What we're looking to do is get those scientists that are doing work and get them back in the sea. We believe that to succeed, you must ascend. On to the next slide. Here's the bottom line up front. That's what BLUF stands for. Those 5 ocean explorers that you see there, we all lived at the Jules Verne Undersea Habitat. We didn't ascend to the surface for a period of 6 days and 5 nights. Great time, great researchers. The female that's in the middle, Shauna, is an MD, and the rest of us are researchers in some way, shape, or form. There are 2 PhD candidates in there. Myself, I'm a PhD, and the guy on the end is a lawyer, but you always got to bring a lawyer with you. So we conducted a whole bunch of experiments during that time, so we were able to get a whole bunch of information, all of which has not been sorted through. But this is what John F. Kennedy said in one of his speeches to Congress. Basically, he believed that we need to explore our oceans because our very existence may come upon it, may hinge upon it. So here was the vision and the mission of our stuff. I'm not going to read it, but the overall is to do a whole bunch of research on the water. Luis, were you asking? Okay. So keeping going, there's a whole bunch of research that can be done underwater now that wasn't able to be done in the 60s. We can get EKG machines underwater. We can get EEG machines, electroencephalogram machines underwater. And we can really, truly find out what's going on in the body. And this is part of what the IANTD Aquanaut program is to get those scientists back in the sea. And it doesn't matter what the science is. It could be biology research on what happens in the cell. It could be some type of other human research that has to do with cortisol levels and raising some of that. So we wanted to make sure that this thing was world-class exploration and try and get a new generation of people interested in doing some undersea research. So with that, we got an Explorers Club flag that's right there. And then Kyle Foster, myself, Shauna Pandia, Doug Campbell, as well as Paul Hawking. We all got together and did a whole bunch of, let me move this off to the side of the screen, sorry. Okay, and we did a whole bunch of research while we were there. That is the Marine Lab, and we were outside there for a little while. You can see it was multinational. Those aren't pot leaves, those are Canadian flags and a couple of American flags. So, bottom line up front is we believe that everything we need to survive on Earth is here. So let me tell you a story about, I did an evaluation of James Cameron's submersible just after he finished his dive to the bottom of the Marianas Trench. While he was down there, he found a sea lice. And sea lice are generally speaking small, like on millimeters or, maybe a little less than centimeters in length, normally. Down at the bottom of the Marianas Trench, he found one that was on the order of just shy of a meter long, and it was albino, like pigmentation. But the bottom line is when he collected that species and brought it to the surface, what we found was that it was a partial synthesized cure, what we had synthesized on the surface, as a cure for Alzheimer's, or a partial cure for Alzheimer's. So at that point, when I did that, this was 2012, I said to myself, I believe that everything we need to cure every problem that we have is here on Earth. We just got to go look for it. And you guys all well know that if you look in the same place you've always looked, you will find the same things that you always found. So what you need to do is look in a different place and you will find stuff. So why the water? Hey, cold water fish, they have a natural form of antifreeze in them. So why can't we use that? There's been some caps that can protect against virus and fungi and protozoa and malignant cells. These are like broad spectrum antibiotics that are in fish. So there's a couple more. Some sea organisms can do some novel delivery methods, novel delivery agents. Basically, what we can use is use some of their blood, use some of the things that they make to deliver our stuff to the people that need them, to deliver any medicine that we have. No surprise that barnacles bind tightly, so why can't we use it as some sort of a surgical adhesive of some sort? Like I said, we're just throwing stuff out there. It's not like these are absolutes, but, you know, anti-tumor agents and sea squirts. And, the aquatic invertebrates that can be prophylactic to lethal doses of radiation. I mean, when you can, these things stimulate progenerator stem cells, which is the CD34 plus progenerator stem cell. Your body makes these. Every time your body goes through all kinds of phases where the cells die off and you make new ones, they make the CD34 progenerator stem cell, your body does, to help you fix things that are broken in your body, mend things that need to be mended. These aquatic invertebrates have progenerator stem cells in them that can stimulate the immune system and possibly fight malignancy. So there's lots of goodness. So what did we do? We do what we call ICE. We're studying isolated and confined environments. These isolated confined environments, it's not just for underwater. This is going to play a large portion of any interstellar travel that we do. We're going from here to Mars. Everybody's all hopped up on getting from here to Mars. Well, think about it. You got to put somebody in a capsule with a whole bunch of other people for a period of 3-4 months on the way out, and then 4 months on the way back, and you have to stay there about 9 to 11 months, depending on the rotations. But this is a long duration in an isolated and confined environment with a bunch of people that you don't know, or even that you know very well. You know, I don't care, my best friend in the world, it would be very difficult to live with them for an entire year without being able to take a break. So this isolated confined environment stuff is a big deal. What we did is we put together a whole bunch of cognitive battery tests for our human subjects, stress-induced physiology, sleep changes, sleep diaries, and then, you know, we tested it on workloads that we did. Some days we did a lot of work, other days we didn't do as much work. So, and, you know, all the write-ups. So here's the study design that we had. We wanted to get evoked potential changes. So this is what we call an EEG or an electroencephalogram. Truly, it's not a true EEG, but what it does is it changes the evoked potential, or it registers the change in evoked potential. We basically did it before we started the dive, then we did it in the midway of the dive, and then we did it at the end of the dive. And then we did a whole bunch of psychological questionnaires that were in concert with stuff that was still going on. And we did them before the mission, during the mission, every day, and then after the mission, and then cortisol samples. So these cortisol samples were really cool because they tested in the saliva. And it was interesting to note that the peak of your highest level of cortisol remains in the morning, and that's when cortisol is peaked. So we had to do the tests in the morning to see what the cortisol levels were and to track how they were doing pre and post dive. Once again, just putting the science in the sea. So the one on the right is Doug Campbell, and that is actually the first EEG that was ever performed underwater. What it does is you basically put the headphones on, and here's him sitting in the lab. You put the headphones on, you put these wet leads on the top of your head. That's why everybody has a towel around them. And basically you do the evoked potential thing. That's when you hear a sound, and then it takes you a time to register that sound by clicking with your finger. So your eyes are closed and you're listening for the sound, and then you click. The time that takes is usually 300 milliseconds. That's why they call it a P300, or an evoked potential. How long does it take to get from the signal from the brain saying push the button to the time that you actually push the button? And that's me administering the test. It's very much shorts and t-shirt under there. It was hot. and sweaty. We did flanker tests, trail making tests, Hamilton anxiety exam, and a mini mental status exam every time we did this. So we recorded some great data. Moving on, the initial preview, when we looked at the collection of these results, there were some significant changes in the mini mental status. There was little change in the mini mental status of the Hamilton anxiety exam, which I didn't expect to be, but there were some real significant changes in the P300 evoked response. Interestingly enough, it seems, and we're not done with the analysis, but it seems that your evoked potential is shorter when you're underwater. That means that it takes less time for you to get it from the synaptic pathways in your brain to your finger. And we thought that was kind of interesting. So we intend to write this up and publish it in a journal. Next, we had some medical lessons learned. So if you are underwater for long periods of time, you have all kinds of problems that could possibly come up. And this is about being an aquanaut. So here's some of the course outlined here. But the HAB had a bunch of first aid kits and so forth and so on. But what we found is that we really needed to supplement those medical kits for sure. For instance, what you see is a whole bunch of people lying down on one side. Since an ear infection can come from being underwater, you are in a warm, moist, pressure-filled environment, and generally speaking, it's not well lit. So it's warm, moist, and dark. Well, that's a perfect breeding ground for bacteria. So what we have to do is take a 50-50 solution of isopropyl alcohol and basically a vinegar and isopropyl alcohol, and we mix it and put it in our ear and just lay there for 5 minutes prophylactically to make sure that we didn't get ear infections. So as an aquanaut, somebody that's going to live underwater, that's something you have to do once in each ear per night. And pretty much it's got to be like, TikTok, you will do it. Interestingly enough, most commonly, we had a bunch of bumps and bruises. What you'll find is that when you're living in an aquatic habitat, everything is wet and does not get dry very well because you're open to the moisture in the bottom of the ocean. When that happened, what we found is that you bump yourself on the metal things that are in there. There's nothing really soft in there. It's a metal chamber. So aside from the seating, it's not really soft. But what we have is you'll bump yourself and maybe you get a small cut. And that cut did not heal nearly as fast as it would have when I was on the surface and I have cut myself, or I've cut myself on a dive and then get back to the surface. Because what you need is that warm, that warm, dry air. That being the case, we also did, we talked about non-steroidal anti-inflammatories are definitely suggested, and acetaminophen, which is basically Tylenol. So this is more of the medical kit continued and what you should be thinking about if you're planning on living underwater. Interestingly enough, we checked stool samples and how people were doing with that. And interesting enough, you may need to get some stool hardener or stool softener, depending on what your diet is down there. So gauze, antiseptic solution, topical pain cream would be good. One of the doors actually slid into somebody's head. It gave a pretty good bounce. So just once again, this is the type of stuff that when you're in this environment, you don't normally think of, but it's the type of stuff that you have around your house probably. So you definitely want to have it on you. Some of the stuff that we did was really cool. Right here, we have a picture of Dr. Pandya, and she's a medical doctor, as you probably recall. And she remotely connected with somebody in Canada, and what she's doing is sharing a virtual reality space. They had a fake X-ray that they had, and they discussed that X-ray. So if the X-ray was taken, you can discuss it while you're in the habitat. You can discuss it with somebody that's an expert, or a radiologist in this case. You can discuss that and kind of do virtual medicine. Even though we had a doctor on site, she wasn't a radiologist, so she didn't understand the break or which way the thing was set, or how, or why the lung looked encumbered or whatever. So it was nice to be able to manipulate and rotate in a 2D and a 3D environment and look at a whole bunch of ailments and try and figure it out. That was the first time that type of technology was ever used. And you can obviously see the direct and practical application of that when you go into space. I mean, here you are, you're 100 days out, and let's say it's your doctor who fell down and hurt himself. Now you have nobody to help. So everybody has to play every role. Lots of good virtual decision making and discussion. We did these iSantos heart rate monitors, and we tried to waterproof them. That's basically a RR variability monitor. Basically, it'll do just heart rate over time. It's been deployed in several different exercises that NASA deployed it a couple of times, but this is the first time it was demonstrated in a wet and dry, or we tried to do wet and dry environments. So those are some of the guys trying to shield them up, but the data that came from that was pretty darn incredible. We were able to put together a bunch of heart rate variability information, which showed to me that, yeah, your heart rate variability changes and it is under stress. And I believe that when I did my dissertation, I proved that carbon dioxide can change the autonomic nervous system and stress it. I also believe further now that we can do something about decompressive stress. So this might be the key to unlocking true real-time decompression, is whether or not your autonomic nervous system is stressed. And that has to do with the heart rate variability. But more to follow on that. We put together a whole bunch of stuff. We partnered with another doctor who put together this machine. Basically, it was to test breathing and how much you could breathe and how your ventilations, and in an emergency, what we could do for inhalatory and ventilatory devices that, once again, 3D printed. And if you're on a space station, you can just get the code and print that, and you don't have to go get it back from Earth. But printing in space or printing while you're underwater is going to be really important. Yeah, he guided us through some troubleshooting. That was the overall takeaway. We needed a really good connection to the surface, because if you think that you're the cool person when you're doing the experiment and you're a person that's living underwater and you're the aquanaut, the true heroes are the people that are up top, because they're the people that are manning the control van and making sure that you have the required air that you need and the required information that you need, and the connection with the people on the surface and the experts that you need. So it was an interesting realization as you went through this process. All right. We had a whole bunch of logistical lessons learned. Oh boy. Just alone from getting people from 2 different countries to one airport on time and meeting, that was significant. And then lodging, time of travel. There's all kinds of airline restrictions and so forth. So, you have to make sure to pack what you only need or what you really need. So that was an interesting lesson learned. We wrote up an entire report, which I will make available to IANTD headquarters for the Aquanaut program, and it tells you a lot more of these lessons learned. But as you can see on the right there, that is one of the boxes. That was the size of the box, and there's a diagram right there. That was the size of the box that we had to ship stuff down to the habitat. So lots of logistical nightmares. We had some problems with resupply. For instance, we had some pre-prepared meals, and they had to be stored in a refrigerator, freezer. But when the initial selection was done, what happened was, for the first 2 days, we basically had the same meal because the person didn't look in the box to see the variation. So it kind of gets old when you have the same omelet, for 4 meals, for 4 or 5 meals in a row, breakfast, lunch, and dinner. So that kind of was a pain in the butt. But there's a lot of airspace management, some food prep issues, going back and forth. It was kind of a difficult thing. We found that paper records, oh boy, what you need is that waterproof paper that you can write on. This paper book wound up not being very cool. I can tell you that having internet access for me was very, very important. It was a crucial link. We did a lot of communication, a lot of outreach, and talked to a lot of experts, so we were able to ask questions about what was going on to the people that were at school. I even taught an underwater class for the University of South Florida. While I was underwater, I taught one of my lectures while I was there, so that was kind of neat. Some of the other takeaways. Oh boy. you'd be surprised what you do to tie back your hair when you are underwater. You know, the normal stretchiness of the rubber bands don't tend to hold very well underwater. And there was a definite need to reduce the boredom. So one of the guys wound up putting together a whole bunch of ideas to have some fun and games. But this is just people management while you're underwater, right? This is about being an aquanaut or an astronaut or somebody in an isolated or confined environment. You've got to figure out something to take up your time and keep your mind off of just being bored or lonely. Kind of like we're all in isolation right now, right? All right. Like I said, we did a lot of outreach. We talked through the Aquanaut program. I taught the Aquanaut program to everybody that was here, and they got to experience it firsthand. We did, 7 total outreaches. We had a bunch of media outreaches and podcasts and, you know, and talking with those people just to share what we were doing. And basically, overall, here was the lesson learned from what we did, where we were going, and we got a lot of lessons learned. Now, our intention is to take this and move it to the world record. So the current world record is 72 straight days underwater in a habitat. We intend to break that record sometime next year in 2021 with a 100-day undersea mission. And guys, I'm telling you, we need aquanauts that are trained to help ferry gear for us up and down, to help be the surface people, to help us with some of those logistical problems and so forth and so on. So we had a lot of learning that went on, but we still had a lot of things to do to express this boundary, to push this boundary over 100 days, because nobody's ever done it before, because it's no kidding hard. So with that, what I'd like to do is take your questions, and I think I can jump back to the presentation mode here and see if anybody's got questions. Deny, I don't want anybody to control my device. Why are you trying to control my device? No. Okay, so everybody's unmuted right this second, so if you have a question, go ahead and ask it. If we could do this one at a time, that'd be fabulous.
Joe, I have a question.
Yes, sir.
So, what sort of qualifications are you looking for the aquanauts to support the mission?
So what sort of qualifications? I need hyperbaric positions, and I need just basic divers. So I figure if I break it up into 10 days worth each, then I can get 10 sets of 10, if you know what I mean. So yeah, I'm looking for any kind of diver that's willing to help this as we go through it. And, you know, you can leave your name with headquarters if we can get it, but, you know, any type of a diver that has gone through the Aquanaut program would be helpful, because they understand the logistical nightmare that's going on and how to transport stuff back and forth.
All right, so the Aquanaut program would be a prerequisite to participate?
The chat here somewhere.
So I hope I answered that question. Yes, I believe that the Aquanaut certification is a prerequisite to people helping out, because you just got to understand what's going on. And if you're a physician, we can make you a hyperbaric physician, and you can stand 10 days worth of the watch down there, because we're going to need some help. Any other questions? Luis, can you hear me now? Can you hear me, Luis?
Yes, Joe, you have a question here. Which essential team roles would be common to all science missions?
I'm sorry, I couldn't hear the question.
Which essential team roles would be common to all science missions?
So the essential team role that would be common to all scientific missions. My opinion is that what you need is somebody that is interested in their own science. So the mission specialist is common to every role. So, and that's what most of the guys were. I happen to be the principal investigator, but I was also a mission specialist at times. So the doctor was also one of the investigators, the MD. She was an investigator, but she was also a mission specialist. So the mission specialist role that can basically a little bit of everything. You need a little bit of medical training. You need a little bit of scientific knowledge and background. You know, and you need to be able to help with or perform your own scientific experiment. And by God, you need to be a good diver because it's the second that you start kicking up the muck in that one little lagoon, it's horrible to try and see through it. So, did I answer that question?
Yeah. And the other one is, so Aquanaut training program will be a requirement for working as a diver on a mission.
Yes, and I think it's really important because not only are we going to break the world record, we're going to do some amazing science. So I need everybody that's trained in this to understand the implications of the science that they are dragging down there before they get there. You know, so they got to understand pressure changes. They got to understand saturation and the fact that we cannot surface. It's not just the world record that's at stake. We don't know because the longest time anybody's ever spent underwater is 73 days. So 72 days. So nobody knows how to calculate the decompression. We're still figuring that out. And, you know, I want to make sure that everybody has that training so that they understand it. Did I answer that?
Yes.
Good. Good. Any other questions?
Okay, we got here, Joe. Who do you see as being the ghost-like funders of the undersea research?
So what I think the question you asked me was, who is the sponsor? Is that right?
Yeah.
Yeah. So we're seeking some funding sources right now. Currently, it's individually funded, but if anybody's got $150,000 they're not doing nothing with, I would give them the gold letter sponsor for it and name the habitat after them. But so far, we don't have individual sponsorship. Right now, it's all coming out of the International Bank of the people who are doing the exploration. Did I answer that?
Yeah. Yes, you did. I don't see any other question coming, Joe.
Oh, I had a quick question for Joe.
Okay.
Sure.
Okay. Are you doing calls for research projects or experiments to conduct during the mission? And how would one get involved in that?
Yeah, so right now we have a current bank of the same things that we did on the 5-day mission, the cortisol samples, the blood draws, the EEGs and the EKGs. So that's currently the host of what we have, as well as mission diaries and so forth, sleep studies. But if you have some information and some science, that would definitely lend to it. We'll definitely take that into consideration. And what we intend to do is once we get this thing moving, we were going to do a lot of this before Corona broke out, but once we get this thing moving, we intend to go to places like NASA and say, what other science would you like to see done? Because they may have some sort of a diary that needs to be kept answering different questions. I don't know, some sort of sample that we should be taking in stool. I don't know, you know. So if you have some of that stuff, you can contact me. My email is pretty easy. It's joe@iantd.com. So if you have some no kids in science that you'd like to contribute to this, I'd love to have somebody on the surface that's doing their own science, if you know.
Yeah, we've got a few ideas for you, Joe. I'll be in touch.
Great, easy peasy.
The other question, Joe, is where can we find out more about the aqua training program?
Right, the Aquanaut training program. So yeah, our Aquanaut training program obviously goes straight to headquarters. We have a little bit of information right now, but it's in its infancy. So basically, what we'll do is hook up with headquarters. They'll hook you up with an instructor, and we can give you a little bit more information. And what it winds up being is you need to do the definition of an Aquanaut is somebody who has spent 24 hours underwater. So in a pressurized tube. So if you want to do that, you need to kind of go through that program, and you'll get the information as you go through the program. But more information is available at headquarters, and you can contact them.
Okay. The other question is, from a mental health perspective, what do you see as typically being a maximum recommended duration for the undersea habitat mission?
Maximum what?
Recommended duration for the undersea habitat mission on the mental health perspective.
From a mental health perspective. Okay, so we're talking about isolationism and confinement. Right now, we do 30-day saturation dives in the Navy all day long, and that is not a problem. And you're locked in the tube with 5 of your closest friends, and you do excursions to go out and do your job during the day, but you have to come back to the bell, and the bell has to come back to the habitat. So with respect to that, 30 days is easy. It has been proven that 72 days is doable. So right now, that's what we have, is that in certain instances, 70 days is doable. The problem is, and this is what Aquanaut, this is kind of what you learn in the Aquanaut classes, you actually have to pick the people that you're going in there with very wisely, because you have 2 type A's that are just going to bang heads for the entire time. You may not get through 40 days. But if you have 2 people that can be amenable and work together, you may be able to get to 100 days. So it's kind of a it depends answer, but there's a lot of thought and psychological impact that has to go into it, and that's why we do psychological studies with saturation divers before we put them in long-term saturation.
Okay. The other question is when the experiment will start and how long it takes the Aquanaut training.
So the Aquanaut training, it takes 1 day. So basically what you got to do is you got to get with an instructor, and currently there are only 2 places in the United States that you can do it. One is the Jules Verne Undersea Lodge, and then the other is the NEMO mission, which is generally located in the same spot, only it's out in 40 feet of water off the coast. Those are the only 2 places right now that you can do this type of stuff. So generally it's going to be in Florida. Like I say, I think we can get away with 1 day excursions and a little bit of training. Probably a day worth of training and then a day worth of diving and doing that sort of stuff. And it's also an experience. How many people can say, no kidding, I slept underwater. I lived in a habitat underwater. Not a lot of people can say that. So. All right, so everyone's back on now. Can you guys hear me? I do not know what happened, but I got kicked off.
Yeah, okay. So the question was here, will there be a crossover available for certified civilian saturation divers?
For certified saturation divers? Sure. I mean, I see no problem. If somebody's already a certified saturation diver for like the Navy or something like that, and can show some evidence, absolutely, we'll cross them over pretty quick.
Okay, and what is the requirement to attend the Aquanaut training program?
I think that he said that they have to be a rescue diver or better. Guys, thank you very much for attending. Really appreciate it. I hope you got some good information out of it. At least we'll have this stuff available for you online. So thank you again and have a great day.
Okay. The person said here that he apologized, but he couldn't hear the date when the experiment and the project it will take.
We intend to do it this time next year, like about May of 2021.
Okay. How about that? And any possible training in the Southeast Asia, such as Malaysia or Indonesia?
That would be fabulous if we had a habitat that was out there. So yes, if somebody wants to build a habitat and put it out there, that'd be a great place to do it.
I don't understand exactly the question, but how does one take the class?
Basically, you just contact IANTD headquarters. They'll hook you up with an instructor, and we'll be able to start teaching it. It's pretty much that easy. You have to be a rescue diver or higher, and that's it.
Okay, Joe. I think that's it.
Good. All right. Well, thank you very much. I appreciate everybody's time. Have a great day.